Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Today we present about rework and rehabilitation of machine component. Firstly, I want to introduce myself. My name is NAZRIE bin Ahmad Afi'i. My fellow partner is Muhammad HILMI, Muhammad HAZIM and Muhammad NABIL. Okay. Firstly, introduction. Introduction is rework and rehabilitation of machine component refer to the process of modifying or repairing, exciting machinery or equipment to improve its performance, extend its lifespan, or bring it back to its original specification. Number 2 is this can include activities such as replacing worn or damaged part, upgrading or retrofitting with new technology, and conducting maintenance or calibration to ensure proper operation. Number 3 is the goal of rework rehabilitation is to improve the reliability and efficiency of the machinery while also reducing downtime and costs associated with repairs of replacement. Number 4 is replacing worn or damaged part. This includes replacing bearing, gear, seals, and other components that have reached the end of their service life. Next is rework and rehabilitation of machine component can involve such as number 1 is upgrading or retrofitting with new technology. Number 2 is conducting maintenance and calibration. Number 3 is improving the design or layout of the machinery. Number 4 is conducting non-destructive testing (NDT) to check the integrity of the component. Number 5 is applying coating or surface treatment to protect the component from wear and corrosion. Number 6 is providing training to the operators and maintenance personnel to ensure safe and proper operation of the machinery. The specific tasks involved in rework rehabilitation will depend on the type machinery and the specific issues that need to be addressed. Okay, that's all for me. I want to pass our presenter to present about next article. Okay, thank you.
Thank you to my friend. Now I will present about the theory related to surface finish, heat treatments and technology. Surface finish and heat treatments are used together to improve machine components in metallurgy. Surface finish refer to material surface texture and roughness with smooth surface reducing frictions and wear, and roughness surface improve adhesions or grip. Heat treatments improve material properties such as strength and toughness by altering its microstructure. Surface finishing and heat treatments use technology like mechanical finishing, chemical finishing, electroplating, and heat treatments method like induction hardening, quenching, and tempering. Okay, the next is the measurements result that have been made in accordance with the project's drawing. Measurements show that the ukulele project was successfully produced and meet the specified requirements of being less than 0.5 mm in microns. Testing was done using a caliper, and the results show that the project provided satisfactory measurements. In the below is the measurements and the product that we made. Okay, next I will explain about the table that we are measuring by parts. Number one is drawing dimensions, radius 30, plus minus 0.5, and part dimension we got 59.9250, and tools that we use are flexible measuring machines, and the status part is okay. Next is we do the blind hole, 8 blind hole, and the diameter 8 plus minus 0.5. The part dimension we got 8.7542, and also we use flexible measuring machines, and the status is okay. Next is 30 plus minus 0.5, part dimensions 29.5892 millimeters, and we use flexible measuring machines, and the status is okay. Next is 90 plus minus 0.5, and part dimension 89.8130 millimeters, and tools that we use flexible measuring machines. The status is okay. And next, drawing dimensions 40 plus minus 0.5, and part dimension 40.1150 millimeters, and tools that we use flexible measuring machines, and the status part is okay. And next, the total length that we measure is 210 plus minus 0.5, and part dimensions 210.1285 millimeters, and tools that we use flexible measuring machines, and the status is okay. And next is drawing dimension 20 plus minus 0.5, part dimensions 90.8550 millimeters, and tools that we use flexible measuring machines, and the status is okay. And the last but not least, RA, part dimensions 0.489, and tools that we use surface roughness test, and the status is also okay. That's all for me.
Okay, thank you, Nabil. So I will continue the next slide with 3.0, the appropriate type of surface treatment or heat treatment method. The appropriate type of surface treatment or heat treatment method depends on the desired outcome and the properties of the material being treated. Some common surface treatments include sandblasting, polishing, and electroplating. Heat treatment methods include annealing, hardening, and tempering. It is best to consult a metallurgist or materials engineer to determine the best method for a specific application. 3.1 Processing system used in Project 1. A. Injection molding. In injection molding, a plastic or thermoplastic material is heated until it is in a fluid state. Then it is injected into a mold under high pressure. The material then cools and solidifies, taking the shape of the mold. The mold is typically made of metal and can be composed of one or more parts. The process is used to create a wide range of products, from small medical components to large automotive parts. There are several types of injection molding, such as standard, thin wall, and micro molding, each with its own set of advantages and disadvantages. The choice of injection molding method depends on the product design, material properties, and product requirements. Next, injection process. The injection molding process generally consists of the following steps. Number 1, clamping. The mold is clamped shut by the injection molding machine. Second, injection. The plastic material in pellet or granular form is fed into the heating barrel of the machine, where it is heated until it becomes a fluid. The molten material is then injected into the mold under high pressure. Third, cooling. The mold is cooled to allow the material to solidify and take the shape of the mold. Fourth, ejection. The finished part is ejected from the mold by the ejector pins. And lastly, trimming. Any excess material called flash is trimmed off the part. The entire process is controlled and monitored by the machine's computer, which ensures that the process is consistent and repeatable. The cycle time, which is the time it takes to complete one injection molding cycle, depends on the part size, complexity, and material properties. Additionally, depending on the type of material used and product design, some specific steps may be added, such as pre-treatment of the material, post-treatment of the part, and quality control. And this is the example of injection molding in our project 1, as we can see in the figure 1. The figure 2 is an example of type surface finish treatment that has been set in our project 1. Thank you. I will continue with Muhammad Hilmi.
Hi, my name is Muhammad Hilmi bin Zulkifli. Today, I would like to continue the presentation about justification for the type of surface finish treatment that has been set in our project. The finishing process aims to change the surface of the produced part to achieve a specific objective. Commonly, desired objectives include improved aesthetic, adhesion, solderability, chemical, corrosion, falling or wear resistant, hardness, electrical conductivity, defect removal, and surface friction control. In limited case, this technique can be used to restore original dimension or to salvage or repair parts. There are two main categories of finishing process, and they largely depend on how they affect the workpiece. This process either remove or reshape the finishing or change the finish. The removal reshape process work primarily to alter the surface of a part to achieve a desired finish by removing or reshaping the part. In this project, for the surface finish process, we use a grinding type treatment. Metallic or non-metallic material to give it a smoother appearance by removing oxide layers and impurities on the surface of the workpiece. This will also achieve the desired surface for the 7 functional purposes. In addition, it is widely used rough machining process in which a rotating wheel covered with abrasive particles such as grinding wheel to cut metal or non-metal material fragment from the workpiece, making the surface flat or smooth. The next slide, I will present about project improvement. There are several ways to improve an injection molding project, such as proper part design. A well-designed part can reduce the number of mold cavities, improve part functional, and reduce the overall cost of the project. Second, material selection. Choosing the right type of material for the application can improve the properties of the final product, reduce the cost, and increase the efficiency of the molding process. Third, process optimization. Optimizing the process parameter such as injection speed, pressure, and cooling time can improve the quality of the parts and reduce the cycle time. Fourth, maintenance. Regularly maintaining the mold and the injection molding machine can reduce downtime, improve the lifespan of the equipment, and ensure consistent quality. Fifth, quality control. Implementing a comprehensive quality control program can help identify and correct any issue that may arise during the production process. 6. Automation. Automating certain aspects of the process can increase efficiency and reduce the need for manual labor. And the last one is tooling design and construction. Using advanced technologies and proper tooling design can improve the quality of the part, reduce the cycle time, and decrease the cost of the project. Consulting with an experienced injection molding engineer can help identify the specific areas for improvement for a given project. The last slide for our project is summary. Overall, the project was complete successfully. We also did some work after the completion of this project, including testing the roughness on the surface of this project. In addition, cleaning the machine after it is used. In the meantime, we also follow the safety SOP before and after doing machining work in the industrial machining workshop. Next, we also test this project in terms of the top cover on our project. We found that it worked well. All the problems we faced we were able to overcome without any damage during machining work before and after completing this project. We hope that this project can be developed even better than before without any problem encountered after completing it. Thank you. That's from all.